Hello, dear Sathi students. I am Priyanka Rajeev from Department of Mechanical Engineering, IIT Kanpur. This is lecture 2 of the chapter Laws of Motion. So today we will be discussing the following topics: Newton's second law of motion, impulse, and impulse momentum theorem. So first, we will be discussing about Newton's second law of motion. So Newton's second law of motion, it can be qualitatively expressed as in the following words. It is the rate of change of momentum, which is discussed here, dp by dt. So rate of change of momentum of a body is directly proportional to the rate to the applied force. And so first we will be stopping here and discussing about it. So rate of change of momentum. So momentum, we have seen in the earlier class that we use the letter P to denote momentum. So momentum, so rate of change means change in momentum by change in time. Okay, so change in momentum. So rate means the amount of something with respect to time. Like if I say rate of change of position, that means the change in position by change in time, which is the quantity called velocity that we know. Then there is another thing, rate of change of velocity. Then that can be expressed like this: delta v by delta t. So that is called acceleration. Just like that, Newton is stating that rate of change of momentum. So that is given with this thing, this notation, dp by dt is proportional to the applied force on the body. So applied force is taken as F. So these both are vector quantities that we have seen earlier in the last lecture. So F is also a vector, force is also a vector, and momentum is also a vector. Momentum, a quick recall, momentum is P equal to m v. So velocity is a vector quantity. So in the same direction of velocity, momentum is also there. Like the vector quantity of momentum has a direction of velocity, and the magnitude is the product of mass and velocity. So the Newton's second law of motion is the following sentence. This is like the rate of change of momentum is proportional to the applied force, and it takes place in the direction in which the force acts. So the rate of change of momentum, this vector quantity, has a direction which is along the applied force. So this this statement, if we write it in mathematical terms, it is like this: applied force, and it is proportional to dp by dt. It's a rate of change of momentum. And to write it with an equal sign, we use a constant of proportion. So this k is called constant of, one second, okay, constant of proportion. Okay, so this constant of proportion here is taken as 1, so that we can write it directly as F equals d by dt of mv. Mv is momentum. Okay, so since m is always constant, in most of the cases m is constant, so we can take it outside the derivative sign. So taking m outside, it will become dv by dt. And we have discussed this just now. Delta v by delta t, or when you so delta v by delta t, rate of change of velocity. So if we want to know the rate of change of velocity within an infinitesimal point of time, within a small duration, interval of time, we will tend this delta t to 0. So that can be taken as dv by dt. So dt denotes a small change in time and dv denotes a small change in velocity corresponding to the interval of time. So that is acceleration, right? So acceleration, velocity is also vector quantity, acceleration is also vector quantity. So that is how we get the following expression, F equal to m times a, where acceleration and force both are vector quantities, and the direction of force is along the direction of acceleration. Now we will discuss about the SI unit, the unit in which force is quantified. So the SI unit of force is Newton. Remember, whenever you are writing a unit which is in the name of some scientist, okay, for example, Newton, the unit Newton is named after Isaac Newton. So you have to use small letter n when you're writing it in the full word. The whole word, if you're writing, you have to use the small letter n. And for the unit, when you're writing it just the alphabetically, only the alphabet, if you're writing, you have to use the capital letter. Okay, so just like that, there's another unit of energy or work. Of energy. If you want to denote energy, if you want to denote a quantity of energy, you will be using a unit called joule. Okay, joule or joules. So this is also named after a very famous scientist. His second name is Joule. So this is a proper noun. So this is the name of the scientist, and the unit is always written with a small letter j. And it is when we are writing it in mathematical context, we will be using just the sign of the unit. That will be capital letter J. Okay, just a trivia. I'm just giving you this information. Another unit is called CGS unit. So this is centimeter, gram, and second. Okay, SI unit is like the standard measure of length is meter, and mass is kilogram, and time is second. So in CGS unit, the standard measure of length is centimeter, and mass is gram, and time is second. Okay, so you will be measuring force with the unit of dyne in CGS and the unit of Newton in SI. Okay, and this is the conversion. 1 Newton equal to 10 to the power 5 dyne. So you can just use the conversion like this. Like for example, you could see that 1 Newton, Newton equal to, force equal to mass times acceleration. So mass is kilogram and acceleration is meter per second square. So kilogram to gram, if you write, that is 10 to the power 3, and meter to centimeter is 10 to the power 2. 10 to the power 2. So, and second is the same, so it is 10 to the power 5 dyne. Okay, from Newton, 1 Newton equal to 10 to the power 5 dyne. And kilogram weight, this is also a unit. This is equal to 9.8 Newton. This we are getting using acceleration equal to g. So g is 9.8 meter per second. So this is a standard unit for calculation which is related to Earth's gravity and the weight of the object. So usually in Earth, the weight is a multiple of 9.8 meter per second, because the Earth's gravity is 9.8 meter per second. Like for example, this is our Earth, and I'm placing this 1 kilogram of object on the surface of Earth. So this force of attraction, the gravitational force provided by Earth will be what? F equal to ma. M is 1 kg and A is g. Gravity is what? 9.8. So the force will be 9.8. So if you place something 2 kg, 3 kg, 4 kg, it will be always like multiples of 9.8. If a man weighs 67.5 kg, then the gravitational force that person is experiencing will be 67.5 times 9.8. So this 9.8 is can be removed by taking this 9.8 as a fundamental unit. So that is what we are using when we are denoting force in the units of kilogram weight. Okay, so this is also called kgf, kilogram force. Okay, kgf. Okay, so next thing, now we want to find the net force. Okay, net force. So magnitude, we know that is force times force equal to mass times acceleration. That we know. This is about the magnitude. But what if we want to calculate net force if two forces are acting? For example, this is a body, and you're pushing from here, and you're pulling from here, or else you're having a body like this where you are it is falling and suddenly you're giving a push like this. Okay, so we want to know what is the net force that is acting on this body in various situations like this. So for that, we want to treat force as vector. 2 or more forces will be acting, and we know that forces are vectors. So to find the resultant force, we have to use something called vector additions. Okay, vector algebra we have to use. So let me revise those concepts with you. So you have probably heard about parallelogram law. Parallelogram law. Okay, so that says if 2 vectors are there, P and Q, and they are adjacent vectors, and they act simultaneously at a point, then if that 2 vectors can be represented as 2 adjacent sides of a parallelogram. So this is a parallelogram. This is a parallelogram, and this 2 vectors P and Q are the adjacent sides of a parallelogram. Then the diagonal that originates from the simultaneous point of action of P and Q of the parallelogram can be taken as the resultant R. Okay. Now, for calculating, so this we'll be saying that the angle between these 2 vectors is theta, and then we will be doing the calculation. So let's see how we can find the net force. Okay. So for example, let's see this P and Q as F1 and F2, 2 forces that is acting on this object. So this is the object. Okay, so 2 forces are acting, F1 and F2, at an angle theta. Okay, so we want to calculate the resultant force or the net force that is acting on this object. So this is the net force F. So as per parallelogram, we will be checking whether we can represent these 2 vectors as adjacent sides of a parallelogram. Yes, we can do. So that is, so P is F1 and Q is F2. Okay, and R is F, the resultant force. Okay, now So what are we supposed to do? For the derivation, we have to do a simple trick. What are we doing is, this is F1, or we can say it as our P here. So this is F1. Okay. And we have another vector F2. So in general terms, it is our Q. And here in our specific terms, it is F2, the force. So vector can be any vector quantity, right? Like velocity or acceleration. So any vector quantity, if you want to find the resultant, you have to use a parallelogram. For our case, we want to find the resultant force. That's why I'm saying in our case, F1 and F2 are the two vectors. In general case, it is P and Q, any vector quantity. Okay. So P and Q. And now we will be constructing a parallelogram. So how are we constructing a parallelogram? Like this, okay. So this parallelogram is named as O, the origin. Then this P vector can be denoted as OD. And, oh, sorry. Okay, I have to start over again. Okay, so I'll construct the parallelogram. Okay, so this is P and Q. So P vector and Q vector. And we have a parallelogram here. So it is named O, D, and this can be A and B. Okay. So another thing is that we want to drop a line over here, a perpendicular line to the horizontal line here. Okay, this is a perpendicular. We will get to know about why we have drawn this line sooner. So that is the point C. Okay, here this is the point C. Now we know that the angle between these two is theta. Now we want to calculate the resultant R, which is the diagonal of this parallelogram. Okay, so this R. So as per our situation, vector P is F1, which is equal to OD. Vector Q is F2, that is OQ. And vector R is the resultant of F, which is equal to OB. Now, so in simple terms, we can say, using vector algebra, this is the notation that we will be using. P plus Q equals R. Okay. So how this came? Now we have to talk about the magnitudes. So now what we will do is consider this triangle OBC. OBC, okay, or OCB. Okay, this bigger triangle. Now from Pythagoras theorem, you know that triangle OCB, we know that OB square can be written as OC square plus BC square, right? Now this BC square, now this OC square is a sum of two lines. What are they? OA and AC. So let's split this into two. Okay, OC can be written as AC plus OC. Sorry. AC. Okay, I'll write it once again. OC can be written as OA plus AC. Okay, because it is joining at a common point A. Now, rewriting this sentence again, OB square equals OA plus AC the whole square plus BC square. Okay. Now, that can be treated as equation 1. Now, from triangle OCB, again, we know that, from triangle ABC, we can find this AC, right? So, triangle ABC, we can write something about this. Before that, if this angle is theta, so what will be this angle? This angle will also be theta, right? So to express AC in terms of AB, we have to use what? AB cos theta, right? How that came? Just like this. In triangle ABC, cos theta equal to AC by AB. So in that manner, we know AC equals AB cos theta. Okay. Also, we can understand one another thing. Since this OABD is a parallelogram, this opposite sides are going to be equal. So that means OD and AB is equal. So OD and AB is equal. That means AC can be written in terms of OD, right? So we know, okay, so this can be written as OD cos theta, since AB equal to OD. Okay. Now, that is equal to Q cos theta, that we know, because not Q, it's P, right? So that is P cos theta. Now, another thing is that if you want to represent BC, okay, if you want to represent BC, you can use what? Again, here, BC by BA or AB equal to sine theta, right? So, BC equal to AB sine theta, right? BC equal to AB sine theta. So AB is what? AB is again OD. So we can write it as P sine theta. Okay, because AB is OD, that we know. So you can write AB sine theta as OD sine theta, and that is equal to P sine theta. Now, magnitude of resultant. So we know this one equation is there, that we know. So we know this equation and we know these substitutions, right? 2 and 3. So 3. Now substituting, we know R equal to, not there. We have to write this equation, right? We will be substituting in this equation. Okay. So substituting in this equation, R or OB square, R square equal to OB square equal to what? OC square. OC square, we know OA plus AC square. So OA is what? OA is our Q, right? OA is our vector Q. So we can write it as O4. Okay, so we have to write it once again. So we know, so these were the equations. One is OB square plus OB square equal to OC square plus BC square. OB square equal to OA plus AC the whole square plus BC square. And quickly write this thing. This is P, this is Q, this is the parallelogram, and this is the triangle. This is the okay. Sir, hello? 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 Yes. Sir, my screen, it is getting erased again and again, so I couldn't continue. Yeah, you can see the recording. Like, I was deriving the parallelogram law and everything got erased, and again I started again. It is getting erased. I don't know which app to use. I'm so sorry. Sir, can I record it and send it to you? Mm-hmm. Okay. Mm-hmm. Sir, which app is being used by students for writing? Sir, I am also using my tab. I'm using Keynote for presenting the PPT. But the thing is, whenever my hand touches and it gets erased after some time. So I'm not able to write it properly also, and I have to be extremely careful. And once something happens, the whole slide is getting erased. So whole writing is getting erased. But then I cannot write it properly, right? Then I have to buy that another tablet kind of thing for writing on the screen, right? So which app they are using? Can you tell me that? Okay. Or else I can continue this. You can you edit this part and do you have the recording? Like, can you take a screenshot of it so that I can? Okay. Mm-hmm. Okay. And actually, the thing is, my writing just got off. So I have to write it over. If you're editing and merging it, then I have to write the exact thing on the paper. Then only that can be continued. So that's why I was asking. Sir, I was in the middle of derivation, so I couldn't continue that. Okay. Then this is the second slide then. Okay. Okay. I'm using the same thing. I don't know if the problem will persist again. I'm just taking a. Oh. Okay. Okay, so let's revise once again what we were saying. So this is P, this is Q, and this is the parallelogram that we were drawing, named O, A, P, and D, and this is the point C, and we have a resultant R. Okay. Now, we were from the Pythagoras theorem, we wrote OB square equals OC square plus BC square, and we wrote OB square equals OC, we split it into OA plus AC whole square plus BC square. Then from triangle ABC, we wrote A. Okay. Sir, hello. Sir, I'll use another app and try. Slides. Sir, I am doing it once again. I'm doing it once again because I'm using another app now. Let me try, because here it won't get deleted. Okay. Okay. So let's recall what we were talking about parallelogram law. The derivation of resultant force using parallelogram law. Okay, so this is P, this is Q, and this is the resultant vector R. Sorry, we'll do one thing. Okay, we will be constructing a parallelogram using this two sides, and then we know this is the resultant R, and then this is the triangle that we drew for finding the resultant. Now we will be naming these points O, A, B, D, and this is the angle theta. So this is also the angle theta. Now we have got these results before using Pythagoras theorem. The resultant OB square is equal to OC square plus BC square, and OC we wrote it as OB square equal to OA plus AC the whole square plus BC square, and AC we wrote it as Q cos theta, and A and BC we wrote it as Q sin theta. Yeah, these were the equations that we had. Now substituting everything to equation 1. This is equation 2 and equation 3. So substituting equation 2 and equation 3 to equation 1, we get OB square, that is R square, equals OA is Q plus AC is Q cos theta the whole square plus BC is P. Because you can see, BC is Q sin theta. Okay, BC is Q sin theta the whole square. OA, AC, and BC. Okay, fine. Wait, there is one small mistake. Sorry, these are P, right? Sorry. P cos theta and P sin theta, because we were calculating with respect to this triangle, and we were calculating AC as AC equals AB cos theta. So AB is equal to OD, which is equal to P, and AC is this, and BC equal to AB sin theta. Again, it is P sin theta. Okay, now we will be just expanding this whole thing. So Q square plus P square cos square theta plus QP cos theta plus P square sin square theta. Okay, P square sin square theta. Now Q square we will be taking, and P plus P square we will be adding these two terms, P square plus cos square theta plus sin square theta plus QP cos theta, which is equal to Q square plus P square plus, because this is 1, plus QP cos theta. This is what R square is. Okay, these are all vectors Q and P. So R is equal to root of Q square plus P square plus QP cos theta. Okay, so this is how we find the net force. Now you can see here in net force, this is to find the resultant vector given two vectors which are the adjacent sides of the parallelogram. Now we were using this for finding the net force that is acting on an object. So when there is two forces, F1 and F2, that are acting on an object and a body, and the angle between them is theta, then we can find the net force as F1 square plus F2 square plus 2F1 F2 cos theta. Now there is some variations, like many situations are there, just like how I have explained before. Like for example, the forces, this is a general situation. The first case is this one is a general situation where two forces are acting on a body with an angle theta between them, F1 and F2. Now, what if this F1 and F2 are acting in the same direction? Then the angle theta will become 0. Okay, so cos 0 is what? Cos 0 is 1. So F1 square plus F2 square plus 2 F1 F2 is what? This will become F1 plus F2 the whole square. When you take the square root of it, that will become F1 plus F2. So that is how you're getting net forces F1 plus F2 when two forces F1 and F2 are acting at the same direction. Now you have another situation where two forces F1 and F2 are acting in the opposite direction, F1, and this is F2. Okay, now the angle between them is what? 180 degree. Okay, so 180 degree angle, so cos 180 becomes what? Minus 1. This will become minus 1. Then this will become what? F1 square plus F2 square minus 2F1 F2. Right? That is equal to F1 minus F2 the whole square. So under square root, if this term F1 minus F2 the whole square comes, that will become F1 minus F2. Now you have another situation where F1 and F2 are perpendicular. like this. This is F1 and this is F2. Now this is perpendicular. Then cos 90 is what? 0. So cos 90 is 0. That means it's not division by 0. Okay. So cos 90 is equal to 0. Then this whole term goes to 0. Then you have F1 square plus F2 square as the net force. Okay. So these are the situation. Now we will see an example. So first case is what? F1 and F2. So this is F1 and this is F2. They are in the same direction. So cos 0 is what? So cos theta is cos 0 is equal to 1. So we know the net force is what? Net force equal to F1 plus F2. That intuitively also you can understand, right? If two people are there, they are pulling a 1 kg object with 5 Newton force and 3 Newton force together along the same direction, then both the forces will be adding up. So that addition of forces will occur for to find the net force. That becomes 8 Newton. Okay, so net force is what here? 8 Newton. So 8 Newton is the net force and mass is 1 kg. So you have to find the acceleration of the object. So how to find the acceleration of the object? 8 Newton by 1 kg, which is equal to 8 meter per second square. Now you have the second scenario where F1 and F2 are acting opposite. So opposite direction means cos theta will become cos 180 because 180 is the angle between both of them, 180 degree. Okay, so 180 degree is the angle between both of them. That will become minus 1. So you know the net force is F1 minus F2. F1 is 5 Newton, F2 is 3 Newton. So that becomes 2 Newton. Now acceleration is what? Force by mass, which is equal to 2 by 1. It is equal to 2 meter per second square. Now the third condition where forces are acting perpendicular. Now we know the net force is equal to root of F1 square plus F2 square. So that is equal to root of 5 square is 25, 3 square is 9. So the answer is root 34. Now the acceleration is root 34 by 1 kg. So this is Newton. 1 kg, which is equal to root 34 meter per second square. Right. Now another very trivial situation. One of the situation is an angle which is like not the regular, the standard angle kind of thing. So here we have taken 37 degree. So you have to substitute this here. 5 Newton. So 5 square is 25. This is 3 square is 9 plus 2 into 5 into 3 into cos 37. You have to find the value of this and substitute and find the net force. Now, this is a very simple question. A body of mass 2 kg is moving with the acceleration a equal to 2 meter per second square. Find the force acting on the body. So here you can only find the magnitude of force. So magnitude of force is mass times acceleration, right? So that is equal to 2 times 2 is equal to 4 Newton. It's very easy question. Second is a force F. So you have you are given a force with vector notation 10I minus 6J plus 8K Newton. So that produces an acceleration of 1 meter per second square in a body of mass M. Find M. So we know force equal to mass times acceleration. Acceleration is given, force is given. Now we want to find mass, right? So acceleration is given as a magnitude here, 1 meter per second. So you want to find the magnitude of force, like force equal to mass times acceleration. Now this is given as 1 meter per second square. Now you want to find the magnitude of force. How to find the magnitude of force? So this thing, if you want to find the magnitude, that is equal to root of 10 square minus 36 6 square plus 64. Okay, that's equal to root of 100 minus 36 plus 64. 100 minus 36 plus 64 is equal to 128. So that is equal to 64 is that's approximately 11.3. Okay, now 11.3 equal to mass times 1. So mass equal to 11.3 kilogram. Okay. Now, sorry, wait, I think I am wrong here. It's minus 6, right? So minus 6 square is plus 36. Okay. Now this will become, I'm so sorry, 100 plus 36 plus 64 is equal to 200. So root of 200. This is approximately 14.142 kilogram. Okay, so now another question. The motion of a particle of mass m is described by y equals ut plus half gt square. Find the force acting on the particle. Now to find that, how to we know that derivative of position. So position is given as a function of time. Okay, here, which is described as ut plus half gt square. Okay, now you know the derivative of position is equal to velocity. So velocity can be determined as dy by dt. Here d by dt of ut plus half gt square you have to take. That is equal to d by dt of ut plus half into d by dt of gt square. Okay, so u and g are constants because we are differentiating with respect to time. So that will become u plus half into g into 2 into t. So this 2 cancels out. That will become u plus gt. So this is velocity, right? Again, the derivative of velocity with respect to time. If we differentiate velocity with respect to time, we will get what? Acceleration. So again, velocity is a function of time here. Velocity is a function of time here. So if you differentiate this velocity with respect to time, you will get d by dt of u plus gt, which is equal to d by dt of u. U is a constant with respect to time. So that is 0, and g times d by dt of t. So that will become g. So the acceleration acting on this object is g. And so the force is equal to mass times acceleration is equal to m times g. We must have learned this equation for uniform motion, uniformly accelerated motions. So for many times we have substituted. The general equation is y equal to ut plus half at square, or we will be generally using s here for displacement. Anyway, for many a case, we especially for cases like falling of object or throwing of an object vertically upward, we have to take the acceleration as gravity. Okay, so acceleration due to gravity we will be taking. So that substitutes this a to g. So we there we were using g directly, but now here we know that okay, this from the equation of displacement of displacement as a function of time, if we are getting, you can differentiate it twice to get the acceleration. So that acceleration we found to be g here. So in both ways we can prove that okay, this acceleration here for this object which is described by such a displacement function is g. Okay, that's all for today's class. So we will continue the discussion in the next lecture. Thank you.